Welcome to lesson number 2 on trigonometry. Today we're going to be looking at trig ratios for angles between 0 and 360 degrees. Now the traditional formula that you've been used to seeing when we're looking at the Pythagorean theorem is this: c squared equals a squared plus b squared, or remember you can write it like this: a squared plus b squared equals c squared. Now in trig we can also, instead of using a, b, and c as variables, we can use x, y, and r. And I'll show you why we would use these three variables instead of a, b, and c. So if I have a point P and it lies on the terminal arm, so the end of the arm of angle theta, then the distance from point P is r, all right? And r is called r because it's the radius of a circle. So here I have point P, and that's where point P terminates, which is why it's on the terminal arm. And if I look at this point P, the distance from the origin, which is 0, 0, right? So the origin is 0, 0 on my graph. The distance is also equal to the radius of the circle if I remove point P around this circle 360 degrees. Now, x and y is going to be the distance, the horizontal distance and the vertical distance from the origin to point P. And that's why if I want to determine any of the lengths of x, y, or r, I can use Pythagorean theorem because I have a right angle triangle that's formed with this angle theta. And of course here r has to be greater than 0. Sketch the rotation angle in standard position and calculate the exact distance from the origin to the given point. Where appropriate, write the answer in simplest radical form. All right, so first of all, let's look at point P, and we're gonna draw this on a Cartesian plane where we have our positive and negative quadrants. All right, so point P is -5 and 12. So -5 on the x and +12 on the y. So I would go -12 units, or sorry, -5 units this way and +12 units up. And that's point P. And point P is going to be forming a right triangle, and we're going to be rotating counterclockwise. Now, what we want to do is we want to say the exact distance from the origin, right? So I know I've gone -5 units in this direction and +12 units in this direction. What I'm looking for is the distance from point P to the origin. Here I can use my Pythagorean theorem. And so I'm going to say that d squared is equal to 5 squared plus 12 squared. So d squared is equal to 25 plus 144. 25 comes from 5 squared. 144 comes from 12 squared. If I combine these, d squared is equal to 169. And the value of d is equal to the square root of 169. So d is equal to 13. Now we'll do the same thing for this example B here. So again, make my Cartesian plane, and so I can incorporate my positive and negative units here. But in this case, I'm using point Q, and the coordinates for point Q are -2 and -6. So -2 in this direction and -6 in this direction. And notice how I'm not making an actual scale here. I'm just kind of putting like ballparks as to where I think these coordinates are going to be. So -2 and 6, and so I have -2 in my x direction and -6 in my y direction. And again, I'm looking for my distance, and that's point Q there. And so I need to use my Pythagorean theorem again. So d squared is equal to -2 squared plus -6 squared. D squared is equal to 4 plus 36, or d squared is equal to the square root, or sorry, d squared is equal to 40, but d is equal to square root of 40. And note how they want us to use, where appropriate, write the answer in mixed radical form. 40, I'm not gonna have a rational number here, so I can express this as mixed radical form as 4 times 10, or 2 square root 10, and that would be my final answer. So let's complete the following. If I have the sine ratio, sine theta is equal to opposite divided by hypotenuse. So opposite divided by my hypotenuse. When I have the cosine ratio, cosine theta is equal to adjacent divided by hypotenuse. And the tan ratio is equal to the opposite divided by the adjacent. So these are known as our primary trig ratios. All right, and remember the opposite side is in reference to an angle theta. So if this is our angle, this is our opposite side here. If this is our angle, this is the adjacent side. And then my hypotenuse is always directly across from my right angle. My hypotenuse always directly across from my right angle, and it's always going to be my longest side as well. Now what we want to do is, for example 2, we want to write our primary trig ratios, so opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, in terms of x, y, and r, because remember this is what we're using in trig now, are these variables x, y, and r, where x is horizontal, y is vertical, and r is my radius. So if this is my angle theta, then my sine of my angle is going to be my opposite over hypotenuse, which if this is my right angle is going to become y, because that's opposite, over my hypotenuse, which is r, y over r. Cosine theta then is going to become adjacent over hypotenuse, which is going to become x over r. And my tan theta is going to be equal to the opposite divided by my adjacent, or y divided by x. Point 15 and 8 lies on the terminal arm of an angle theta shown. We want to calculate the value of r, and then we want to determine the exact values of the primary trig ratios. So first thing we're going to have to do, find the value of r, is use our Pythagorean theorem. So this point is 15 and 8. So 15 and 8. If we're using Pythagorean theorem here, we're using y squared plus x squared, or x squared plus y squared. So r squared is going to be equal to y squared here, which is 8 squared, plus x squared, which is 15 squared. R squared is equal to 64 plus 225. And r squared then is equal to 289. My value of r is going to be the square root of 289, which is equal to 17. Okay, now we have my value of r. This is 17. Now we can find out what the primary trig ratios are. So let's see, sine theta is equal to y over r, 7 yellow rabbits. So y was 8 and r was 17. Cosine theta is x over r, and that is equal to 15 over 17. And last, I have my tangent, which is equal to y over x, and that is equal to 15 over 8. Oh, sorry, no. Y is 8. That is 8 over 15. For this next example, I'm going to do part 1 and part 2, and part 3 you'll be able to complete by yourself after watching me. So consider an angle theta in standard position with the point P of x is 1 and y is root 3 on the terminal arm. we want to show that the value of theta is equal to 60 degrees. All right, so x is equal to 1, y is equal to the square root of 3. Now, we want to show that the value of theta is equal to 60 degrees. So if I have tan theta is equal to y over x, which is equal to root 3 over 1. So this is square root of 3, and this is 1 here. So when we're calculating using tangent, remember if I want to find the inverse, or sorry, if I want to find the angle, I have to use the inverse tan. All right, so I'll have to use the inverse tan of this ratio of square root of 3 over 1, which is just the square root of 3. So inverse tan, and first of all, you'll have to make sure your calculator is in degrees for this. So in order to get to degrees, I went to mode, and I switched from radians to degrees. And so if I take the inverse tan of the square root of 3, I get 60. So theta is equal to tan negative 1, or inverse tan of root 3, and that is equal to 60 degrees. Now we want to find the value of r. So we need to use our Pythagorean theorem here. Well, r squared is equal to x squared plus y squared, or 1 squared plus the square root of 3 squared, which is equal to, well, 1 squared is 1, square root of 3 squared is just 3. That's equal to 4. If I take the square root of 4, my value of r is equal to 2. So let's complete the following using x, y, and r. X is equal to 1. Y is equal to square root of 3. And r is equal to 2. So if I wanted to write the sine ratios for sine 60, cosine 60, and tan 60, I would use the square root of 3 over 2, 1 over 2, and tan 60 is y over x, so square root of 3 over 1, which is just equal to square root of 3. Now, part 2. So the rotation angle in part 1 is reflected in the y-axis. So complete the following. The point Q, x, y, has coordinates. So if it's reflected from this, then instead of this being 1, this is going to be negative 1. And my value going up is going to be square root of 3 still, because it's just being reflected in the y-axis. So my y value is actually the same. So now we have negative 1 and square root of 3. The reference angle here, if it's just reflected, that means we're adding. So if this is 60 degrees up here, then that means that this difference here would be 30 degrees. And so if I'm going another 30 degrees away from 90, this is going to be 120 degrees, and the reference angle is going to be the same. So my reference angle is 60 degrees, and my rotation angle is 120 degrees. And I can get these values, again, by remembering that my this line is just reflected across. So this angle, where this was 60 degrees, which is my rotation angle, and in this case, in quadrant 1, my reference angle. This reference angle is also going to be reflected, being 60 degrees. But if I wanted to find out what my rotation angle is, remember I can just go 180 degrees minus my reference angle, which is 120 degrees for my rotation angle. Now the sine of 120, so y over r is going to be root 3 over 2, right? Where r is also going to be reflected as 2. My cosine is going to be, my cosine of 120 degrees is going to be negative 1/2 this time, because x over r, negative 1 over 2, and my tangent is going to be root 3 over negative 1, or negative root 3.